Okay, so now we're going to do absolute value inequalities, and these are actually more popular than you think, okay? So let's say we have this, the absolute value of x is less than 13. What we have to remember here is that the number that goes inside of here can be a positive or a negative, but the answer has to be a positive, okay? And so what we're going to do here, I'm going to show you what this technically means, but we don't have to do it that way. I just want to show you that when we have the absolute value of something is less than something, you can rewrite this as the opposite of this, so negative 13, with this symbol, then the x without the absolute values, then this symbol, then this number. This is what this means, like by definition, okay? It means that x is going to be larger than negative 13, but less than 13. It's going to be some number that's between negative 13 and 13. Okay, so you can set it up this way to solve, but if you try to apply that to other kinds of, like if we reverse the sign greater than 13, it doesn't work that way. So you'd have to be careful. Okay, so I'm going to show you another way to be able to solve these. Remember when we did absolute value equations? Like if we had absolute value of x is equal to 13, remember that? We would do, let's say it was equal to 13. I said, oh, well, you have to do x is equal to 13, and you have to do x is equal to negative 13. You had to do two of them. One of them had to be positive, one of them had to be negative. We're going to do something very similar to that, okay? Only we got to change this sign. So when you have an absolute value is of something, and it can be absolute value of x is, well, we'll do it in a minute. Let's say it's a greater than 13. Then you would do something very similar. What we're going to do is we're going to take the x, just remove the symbols, and less than 13. That's one of your answers. But now we're going to have another answer. We're going to say x, we're going to write the x, then we're going to reverse the sign. So now it's going to say greater than, and then we're going to change the sign of this. We're going to change the symbol, change the sign. Change the symbol, change the sign. Symbol becomes greater than, sign becomes negative. And so now x is greater than negative 13. So x is larger than negative 13, but smaller than 13. And so we can actually write it the way I showed you a minute ago, which is x is greater than negative 13, but less than 13. And now if we wanted to write our answer in interval notation, it would be negative 13 up to 13. There we go. But what if this was a greater than symbol? If it was a greater than symbol, then it would work out a little bit differently. Again, we're going to write x is greater than 13, and then we're going to write x, change the symbol, less than, change the sign, negative 13. So what this is saying is that x is less than negative 13, so that's negative infinity up to negative 13. And it's also greater than positive 13, so that's union 13 up to infinity. What I mean is, I don't mean at the same time. I mean it can be either less than negative 13 or it's going to be greater than 13. So it's either going to be between negative infinity and negative 13 or it's going to be between 13 and infinity. And so that's the idea of how to do these absolute value inequalities. But sometimes you wind up with some crazy circumstances. For example, you may have the absolute value of x is less than negative 11. Okay? This has no solution because remember, an absolute value is either 0 or positive. It's never negative. So this can be 0 or this can be a positive number. But no 0 and no positive number is ever less than a negative value. Therefore, there is no solution here. You cannot have 0 or a positive value being less than a negative value. Okay? But what about the absolute value of x greater than negative 11? Well, this is all solutions. We would say negative infinity up to positive infinity. It's all real numbers. Every number makes this true because absolute value of x will always be a 0 or a positive number, and 0 and all positive numbers are already greater than negative 11, so every number will make this true. Okay? And so what we're going to do in the next video is we're just going to do a couple of examples of solutions to these.